So good morning. Today we are going to discuss about object-oriented programming concepts. So before that, we have to know what are the languages for object-oriented concepts following. Similar, Smalltalk, C++, Modular Tree, Silos, EFL, Oberon, Java, Ada. These are the main object-oriented languages. In addition to this, Python is also one of the object-oriented language. So from this topic, the question will ask like that, explain object-oriented concepts or explain polymorphism or explain inheritance, like that they can ask. So you have to write answers with the help of one programming language. You can take Java as an example, or you can take Python as an example, or you can take C++ as an example and explain with that example for that concept. Okay. So in exams, usually they can ask about object-oriented concepts. These all concepts you are familiar, but even though I am refreshing the topics, so the what are the main characteristics of object-oriented programming languages? The first one is abstraction. So what do you mean by abstraction? Abstraction means we are hiding irrelevant information from the user. So, how we will implement abstraction in the program? We will implement abstraction using the function concept or subroutine concept. So, for example, when we are having a say main program, that program may contain more than two or three functions. So each one of the function is having a name, but the function is written anywhere. So the user or software developer is actually uh, because he cannot see the implementation details of that function. So it is actually hidden for the user. Okay, so we can implement abstraction by giving a name to a program fragment. So that program fragment can be called as function or subroutine or procedure. Okay, so that is abstraction. Encapsulation, we all know that in every OOPS concept there is a term called class. And what is class? Class is a wrapping up of methods and variables. Class will contain methods and variables all together. So in our concept, we will combine all the variables on the methods together, and that is called class. So class is an example, or it is not an example, it is the way of implementing encapsulation in the programming languages. Then inheritance. So in our daily life also, the whatever features our father is having, that features will be inherited to us. And whatever properties my father and mother is having, I will get that properties from them. So that is the way of inheritance. Like that, we can increase the reusability of the programming. For example, in an IT company, we have to develop a software. For that software, there should be a lot of modules. And some modules are already implemented in the company for the previous projects. So the implemented modules will be stored in the library. So when we are starting to develop a software, we have to check whether any module is present or any module is developed previously in the company. Then we can just extend the properties of that class to the existing class, or we can just reuse that code to our program. So that is the inheritance concept. So inheritance, we will have a super class or base class or parent class, and we will have a child class or derived class, and we can inherit all the properties of parent class to child class. Then polymorphism. Polymorphism, there is a common function to different type of data type. So we can write same name of function in different classes, and each one of the function will implement, or each one of the function will work differently based on the parameters. So if the parameters are integers, then it will work for the integers. If the parameters are floating point numbers, then it will work for the floating point numbers. So the name should be same. That is polymorphism. So we can discuss the different types of polymorphism and all. So now we are discussing each one of the feature in detail. So for the abstraction, I am not giving example here because we have already discussed subroutine, procedure, function and all. So you can write any one of the example from any programming language. Take one example and write one function inside that, and that is the implementation of abstraction. Okay. So abstraction is mainly we are taking a program fragment and we are storing anywhere, and we are giving only one name, and that name is only specified in the main program. Okay. So നമ്മളൊരു ഫംഗ്ഷൻ എടുത്താൽ ആ ഫംഗ്ഷനെ നമ്മൾ പേര് എവിടെയെങ്കിലും ആ ഫംഗ്ഷൻ നമ്മൾ എവിടെയെങ്കിലും സ്റ്റോർ ചെയ്യുന്നു, ആ ഫംഗ്ഷന് ഒരു പേര് കൊടുക്കുന്നു, ആ പേര് മാത്രം നമ്മൾ മെയിൻ പ്രോഗ്രാമിൽ സ്പെസിഫൈ ചെയ്യുന്നു. ദാറ്റ് ഈസ് ആക്ച്വലി അബ്സ്ട്രാക്ഷൻ. സോ വി ആർ ആക്ച്വലി സപ്രസിംഗ് ദ irrelevant information. Okay. These are the advantages. The first one of the advantage when we are implementing abstraction or when we are implementing function wise programming. So different functions will work independently. So we can execute each one of the program segment independently, and we can check the errors independently. And after checking the errors, after the execution independently, we can we can combine all the program fragments together for a particular software. So each one of the program fragment will work independently. That will reduce the error, and that will increase the efficiency also. And what is encapsulation? It's an object-oriented concept that binds together the data and functions that manipulate the data. So, encapsulation, there is an example. This is a difference between abstraction and encapsulation. You can read for the exam. Then this is an example of encapsulation in C++. This is a simple example. Here you can see one class, that the class name is program, and inside that class there is a class again, that is account, and inside that there is a variable as well as a function check balance, variable account balance. So account balance is a variable, check balance is a function which is included within the class, or we can call it as they are wrapped out inside the class. So this is an example of C++. And here you can see the example in Java. Here also we are having a function we are having a class employee, and inside the class there is a variable, that is private variable, and you can see the function also gets salary. So that variable and the function, both of them are included within the class. So this is also example of encapsulation. And this is the example in Python. You can see here the class name is person, and there you are having a variable age, and you are having a function greet, and this function and variable, both of them are included within the class. That is also example of our encapsulation. So clear? So you have to explain at least one programming language, take that example and explain the concept. Then third concept is inheritance. So you can see the figure here. The animal is the parent class, dog is the child class, and animal parent class is having two variables or two features, that is age and weight, and both of them can be inherited to child class. So inheritance means we are creating a new class from an existing class. So the every features or methods or variables which are present in the existing class that can be inherited, that can be reused in the new class. That is inheritance. So we are having some terms, the parent class, super class, base class. This is the name for existing class. And whatever we are creating a new class, then that class can be called as derived class, child class, like that. So derived class can inherit all fields and methods of the superclass. Fields means variables. In some languages like Ada, Simula, where the variables are called as fields. So derived class can inherit all the variables and methods of the superclass. And derived class can define additional variables or additional methods in the body itself. And here the derived class can override also, that we will discuss in detail. So this is the another concept. Here you can see the example of inheritance in C++. So this is an example of C++. Here the widget is a base class and push button is a child class. So for the inheritance purpose, they are using colon simple. So this is a meaning. Push button is a child class and which is inherited from widget. So this is a syntax for C++. Okay, so here you can see same function name in different classes that we will discuss later. But again, this is the syntax for C++. So this same classes, how we can implement in different programming language, we can discuss the syntax. First, the Python. Python also there is a widget is a base class and push button is a child class. So this is the syntax for the Python. Python, we will write class name, then brackets, base class. C++, class name, colon, access specifier, then the base class. Java, public class name, extends, base class. Ada, data type, class name, is new, base class, with. So these are the syntaxes. So you can see for the C++, you have to specify the access specifier before the base class. That I will discuss that about the visibility feature. So in C++, we have to specify the access specifier of base class before inheritance. Okay, but in the Java, there are all the base classes will be taken as public. All the base classes will be taken as public. So there is no need of specifying access specifier. But even though in Java, in every inheritance, every child class will start with the public keyword because all the base classes are taken as public. So the all the child class will start with the public. And here they are using the keyword extends. And in Ada, they are using the keyword is new. Is new. Okay, so these are the syntax differences in different programming languages. So this is types of inheritance. These all inheritance are present in some languages. Some of the languages are omitting some inheritances. But even though we can generally uh, say that there are 5 types of inheritance. So one is single inheritance. That means there is one parent and one child. One child can take all the features from the one parent. Multi-level inheritance, there should be the level of parents. The first grandparent, then parent, then child. So the parent can take features from grandparents, child can take features from parent, and child can directly take features from grandparent through parent. Okay, so here the class A is a grandparent, class B is a parent, class C is a child. So class C is taking features from class B and class B is taking features from class A. So through this multi-level inheritance, class C will get the features of class A and class B. Okay, so this is Hierarchical inheritance. Hierarchical inheritance means one parent, two child. So in our life also, the father is having two children. So uh, all the properties which are available to both children. So like that, there is a one class, two child class. So all the features from the parent class which are available to the all child classes. So that is hierarchical inheritance. So one parent and more than one child. That is hierarchical. Then the uh, just opposite to hierarchical inheritance is multiple inheritance. That means there are more than one parent and one single child. More than one parent, one single child. So we can see here class A and class B, they are two base classes. And all the features of that two base classes will be inherited to the child class, class C. So that is multiple inheritance. And hybrid inheritance means the inheritance which can combine any of two inheritance. So here you can see this hybrid inheritance is combining hierarchical inheritance as well as multiple inheritance together. So these are the types of inheritance. And in the case of inheritance, we have to discuss about the visibility features. So what do you mean by visibility features? So we have already seen access specifiers. Access specifiers will determine the scope of the class or scope of the variable or scope of the function. So here there are three access specifiers are present usually in C++ and Java. So public, private, protected. So when you are inheriting a class, this is an example of C++. This is not applicable in Java. So I'm explaining using the example of C++. So when you implementing inheritance in C++, class A colon public B, that means A is a uh, child class, B is a parent class. Here we are writing public B. That means all methods in the B have the same visibility in the derived class. And if we are implementing using the protected, then class A colon protected B, that means the all public and protected members of the base class become protected in the derived class. And if we are writing private before B, then that means all members of the base class become private in the derived class. So these access specifiers, when we are using for the inheritance, that will determine how the variables and methods behave in the derived class. If we are writing private before base class, that means all the variables and methods in the base class will become private members of the child class. If we are writing protected before base class, that means all public and protected members of the base class became the protected in the derived class. Okay, so the visibility and scope of the variables and method from the base class in derived class will determine by the access specifiers. Okay, so this is special case of C++. But in the Java, all the base classes are always public. Python, all class members are public. Uh, Smalltalk, all methods are public. All variables are private. So these are the exceptions. So if they are asking about visibility rules in languages, you can explain with the C++. So the last concept, that is polymorphism. Polymorphism means it is an ability of an object to be treated and used like another object. Or that means one function, it can behave differently. For example, when we are using a word open. So that is a say common word. But that open a door, open a drawer, open a bank account, open a file, open your eyes. So after open, which word we are using, based on that word, the meaning of open will change. That is a real time example. In that case also, we have one example I will take here. There is an add. Add is a function. Inside add, there is three function add, add, add. But inside that function, we are specifying the arguments. The first example, integer arguments. Second, three arguments. First example, two arguments. Second example, three arguments. In third example, double arguments. So the arguments are different but the same name. So when we are executing the function, we don't have any confusion because based on the function call, the function implementation will change. So for example, add of 3.8 comma 6.5. So this function call will execute the third function. Okay, so this is already uh, decided in the compiled time. So I will discuss this is this polymorphism, same name function, different behavior. I already said, but the polymorphism can be divided into two: static polymorphism as well as dynamic polymorphism. So static polymorphism means how the polymorphism should be implemented or how the different functions should behave. That is decided in the compile time itself. That is compile time polymorphism or static polymorphism. So that is also called function overloading. Okay, function overloading, compile time polymorphism, static polymorphism. These three terms are same one. That means the same name, different behavior, but the behavior will be decided at the compile time. So you can see for the overloading, you can see this example. There are three functions of the same name, but the return type and the argument list, the number of arguments, type of arguments, everything is different. Everything is different. And their implementation is already defined based on the function call. Okay, so if we are passing three integer arguments, then it will execute this function. If we are passing two floating point values, then it will execute the third function. So this is already decided in the compile type. So this is an example of method overloading. This is also called function overloading. This is also called compile time polymorphism. And this is also called static polymorphism. And what is dynamic? Dynamic means we will decide at the runtime. The execution will be decided at the runtime. So that I will discuss with example. Here you can see there are two classes, class person and class employee. This is an example of Java. So where the employee is child class and person is parent class. The function overriding or method overriding or runtime polymorphism or dynamic polymorphism, these all terms are same and this can be implemented with the inheritance only. This can be implemented with the inheritance only. If the same name function is present in both base class and child class will override the base class. You should be clear. If the same name function can be exist in both parent class and child class will override the parent class. You can see here the parent class is having a function walk. Child class is also having a function walk. And we are creating the object of child class. And using that object, we are calling the function walk. Which walk will execute? Base class walk or parent class walk? Sorry, base class walk or child class walk? Here, the child class walk function will execute. That is the example of function overriding. And this will be decided at the runtime. This will be decided at the runtime. So this polymorphism overriding is function overriding is runtime polymorphism. Or it can be called as dynamic polymorphism. So we have to explain with the example. So these are about the concepts of object-oriented programming. So later we will discuss